Number 16. Well, all our variables are already over to the right. So I need to move this 12 over. So I'm going to subtract 12 from both sides. That's negative 30. Less than negative 5n. I'm now going to divide by what's in front of the n, which is negative 5. And divide the other side by negative 5, both sides. This gives me positive 6. What happens to the inequality when you divide or multiply by negative? It flips. And there's my answer. Now, we don't like our answer with the variable over on the right-hand side. We want the variable first. So I'm just going to put my variable first. Here's my 6. Now, who in this problem was being eaten? The 6 was. So I'll make sure it's like that. So that's what I would write in the blank right here. This is what we would put in the blank. N is less than 6. 17. Well, notice that this is not an inequality. It says equal. Okay, so great. So 7n minus 9 equals, I put together here 7n minus 8. And move my variable over. Well, this is one of those situations where the variable cancels out and you're left with just a number. Number equaling a number. Now, is this a true statement? Does negative 9 ever equal negative 8? Does that ever happen? No, never. It is a false statement. If you have a false statement, that means there's no solution to the problem. There's no n that will ever make this original equation true. It's never going to happen. We end up with a false statement like this right here that tells you there's no solution. Okay, I'm going to put things together. 6n minus 3n is 3n. Lose 9, lose 1, you've lost 10. Over here, I have a 3n. 10 minus 20 is lose 10. I see that they're the same thing. That tells me that no matter what I plug in for n, it's going to be true no matter what, because the n's are the same. But if I were solving it, my n's disappear, my variables do, and I get a true statement. Whenever we get something that's true, we know negative 10 will always equal negative 10. It'll always be true, which means there's an infinite number of solutions. No matter what we plug in, it's going to work. So we write on this one, infinite number of solutions. N can be anything, no matter what, because you end up with basically one equation equaling itself. So no matter what you plug in, it's going to equal itself. So infinite number of solutions for number 18. 19, we distribute the 9 through, so it's 7n minus 9n, and then that negative 9 times that's going to be minus 9. Over here, I get 4n minus 8. This gives me negative 2n minus 9 equals 4n minus 8. I now move my small. I'm going to add 2n to both sides. Doesn't look like the variable is going to disappear this time, does it? No, it's not. Equals 6n minus 8. I now move my 8 over. I get 6n equals negative 1. Divide by 6, divide by 6. N is negative 1/6. Okay? It's a single one answer. It's a single number answer. Okay? So nothing disappeared there. Our n's didn't go away. If our n's go away, that's when we're going to deal with either an infinite number of solutions or no solutions. 20. 5n, distribute the negative 2 through, negative 2n, and then negative 2 times that 3 is negative 6, equaling 2n minus 6. So I get what? 3n minus 6 equals 2n minus 6, minus my 2n, minus my 2n. N minus 6 equals negative 6. We now move our 6 over, move our 6 over. N is 0. Right? 0 is a number. Right? Don't let that trick you. So again, the n's didn't disappear, so it's not one of those special situations where it's going to be no solution or infinite number. Well, let's see with our very final problem what happens here. N minus 9 equals 4n minus 3n. N, lose 8, lose 1. Looks like they're the exact same. We get a true statement. If you get a true statement, that's always true. That means everybody's going to work. So there's an infinite number of solutions. There you have it.